In this video I'm going to show you how to assemble the EavesDrum PCB yourself. This can be useful, for example, if you are unable to participate in a group order. However, keep in mind that the cost of the components is roughly the same as having the board assembled for you. This is what you need to solder your PCB. A soldering station which allows you to set the solder temperature, Q-tips and isopropyl alcohol for cleaning, side cutters, tweezers, solder. Leaded solder would be ideal since it's easier to work with. Flux, desoldering plate, the PCB, all required components, and a multimeter with continuity and diode test modes. We'll begin by soldering the most challenging components first, the two multiplexers. I will show you two different methods. The first one uses a soldering iron. If you're working with leaded solder, set the temperature to 320 degrees Celsius. If you do not have much experience yet, the easiest approach is to solder each pin individually. Make sure not to use too much solder, otherwise you may accidentally bridge pins and create short circuits. Tin the first solder pad on the PCB. Now adjust the chip so that the pins are aligned with the solder pads. Then solder the first pin to the pad. Continue with the diagonal pad. This will pin the chip so that it does not move anymore. Now proceed with the rest of the pins. As you can see here, the pad and the pin do not connect with the solder very well. Apply a good amount of flux to solve this problem. Apply solder to the tip of your iron first, then touch the pin of the chip. This way the soldering tip acts like a small solder reservoir, helping you control the amount of solder that reaches the pad. How much solder you need depends on the shape and size of your soldering tip. Now remove the residue of the flux with a Q-tip and some isopropyl alcohol. Repeat the same steps with the second side of the chip. After all pins of the chip are attached, check the connection with a multimeter. Set the multimeter to continuity mode. First check that no two pins are erroneously bridged. Then check that all pins of the chip are connected to the PCB correctly. For the second chip, I show you how to solder it with a hot air station. First, tin all of the solder pads. Select a temperature of about 400 degrees Celsius and an airflow of 25 to 50%. Hold the chip in place with tweezers. If it gets pushed away by the hot air, reduce the airflow. At the end, clean off any remaining flux residue. Next, solder the clamping diodes. Here I didn't use any flux, but that resulted in several bad solder joints. So make sure to use flux, and you may also want to tin the pads first to get a better connection. After you're done, check all the connections with a multimeter in continuity mode. Now solder the resistors. Then the capacitors. Now you can solder the potentiometers. Note that you can use either SMD or through-hole versions. Continue with the switches. Then with the sub-D connector. Note that this video shows an older revision of the PCB. The new PCB uses a 44-pin HD connector. You can also add a 50-pin header for extensions or as an alternative for the sub-D connector. Finally, add the pin headers for the Raspberry Pico. Before soldering the headers, attach the Pico board to make sure that the headers are aligned correctly. Check with your multimeter in continuity mode that none of the 3.3 volt or 5 volt power lines are connected with ground. Last but not least, solder the LEDs. Check that you solder them the correct way. You can use a multimeter in diode check mode to test the polarity if you are unsure. Now that you're done, test your board by connecting it via USB to a PC. The EavesDrum board should show up as a USB drive. Download the firmware from the EavesDrum.io website and drag and drop the UF2 file of your board to the USB drive. This can either be the Pico 2 or the Pico 2W UF2 file. You should now be able to access the EavesDrum UI with your browser.